Imagine a future where quantum computing isn't just a sci-fi dream, but a tangible force powering real-world data centers. What if I told you that this leap is already happening, thanks to a groundbreaking collaboration between ORCA Computing, NVIDIA, and top research institutions? Let's dive into how this partnership is rewriting the rules of quantum AI, and why it's sparking debates about the future of high-performance computing. But here's where it gets controversial. For years, quantum systems have been trapped in labs, too fragile or complex to integrate into mainstream infrastructure. Now, ORCA Computing is flipping the script by delivering a ready-to-deploy blueprint for photonic quantum processors to work alongside NVIDIA's cutting-edge GPUs in real data centers. This isn't just a prototype. It's a scalable, upgradable solution that lets organizations harness quantum acceleration without tearing down their existing systems. How? By combining ORCA's room-temperature photonic quantum tech with NVIDIA's CUDA-Q software and Hopper GPUs, all housed in standard 19-inch server racks. And this is the part most people miss. The system uses Slurm workload managers to unify quantum and classical resources into a single programming environment. For the first time, researchers can train quantum neural networks in operational data centers. Proof that quantum isn't just a future tool anymore. This milestone was achieved through a strategic alliance with Imperial College London and the Poznan Supercomputing and Networking Center, PCSS. Together, they validated the setup in a live data center, demonstrating a distributed photonic quantum neural network. As Richard Murray, CEO of ORCA Computing, explains, this approach gives businesses a clear path to quantum adoption. No massive overhauls, just incremental upgrades. But should we trust that quantum classical hybrids will outpace traditional systems in the long run? Or are we underestimating the challenges of error correction and scalability? Share your thoughts below. The tech at play is as fascinating as it is complex. ORCA's PT photonic processors, designed to operate at room temperature, team up with NVIDIA's Hopper GPUs to create a hybrid system. Unlike traditional quantum setups that require cryogenic cooling, this design integrates seamlessly into existing HPC environments. The CUDA-Q platform acts as the bridge, enabling developers to program both quantum and classical components in one workflow. Krzysztof Kurowski of PCSS calls it quantum-accelerated supercomputing made real today. Yet critics argue that photonic quantum systems might lag behind superconducting qubits in speed. Could this be a temporary solution, or is photonic the future? We'd love to hear your take. This achievement builds on award-winning research from Imperial College, where their work on photonic quantum networks earned the Best Paper Award at IEEE Quantum Week. By running a live system in a production data center, the team has provided a replicable framework for others to follow. Sam Stanwyck of NVIDIA emphasizes the role of CUDA-Q in this journey. Open, high-performance software is the key to unlocking quantum's potential. But here's a thought. If quantum computing becomes the new standard, what happens to the decades of classical infrastructure we've built? Will we see a full transition or a hybrid era where both coexist? ORCA's momentum is accelerating. From the UK's National Quantum Computing Centre to Montana State University's recent deployment of photonic systems, the company is proving that quantum isn't just for governments and academia. Enterprises across Europe, North America, and Asia are now testing these systems for AI, optimization, and machine learning. Yet one lingering question remains. How soon will quantum-enhanced data centers become the norm? And who will lead the charge? Let's discuss in the comments. For now, one thing is clear. The future of computing is no longer just about faster chips, it's about reimagining the very fabric of how we process information.